Please subscribe math.com for any query, comment or email.
Hello everyone. Today we are going to discuss another method of factoring the polynomials by means of making groups. Keep one thing in mind that you have to use this method only if the given expression is of the form like this and the given expression don't have the common factors. So it is clear from this expression that there is no factor that is common in all the four terms. Okay, so in case when you have no factor that is common in all the four terms, then you have to check whether there are factors that are common in the pair of terms. Okay, so it is clear from here that this pair have a common factor that is A and this pair have a common factor that is B. This means that the pair have the common factor, so we can factorize the given expression by making the groups. Okay, so after checking the are there any factors in all the four? If there are no factors common in all the four, you have checked either there are common factor in the pair of the terms, then you can factorize this by making groups. So let's take an example and find out how you can factorize the polynomials by making groups. So the example here, so we can solve this polynomial as x cube plus 3xy square minus 2x square y minus 6y cube. What you have to do is you have to make the groups. Now how you can make a group? You have to look very carefully here. Can we make the group like this? Yes, we can make the group because in both of them here the common is x and here the common is y. But one more case is we can also make the groups as this and this, okay, and this term and this term. Why? Because in these terms we have to reduce the expression as maximum as we can. So we have to choose those pairs that will basically minimize the expression. So by making the previous pairs we have here x and y, but in this case we have x square and y square. It means by making pair in such a way we can reduce the expression in a better way. Okay, so we can write as x cube minus 2x square y plus 3xy square minus 6y cube. Okay, then after this we have to find the GCF of these pairs. This is pair 1 and this is pair 2. Okay, this GCF is the greatest common factor. Here the common in both the terms is x square. Okay, so we'll write x square here and GCF is here is y square, as y square is common. 3y square is common in both the terms. Okay, GCF we have discussed it in detail in the previous lecture. You may refer to that. Okay, then we will take the GCF common from these, or we can break this term as x into GCF, that is x dot x square minus 2y into x square. We have separated the GCF of the first pair, then plus 3y square into x minus 3y square into 2y. Okay, now what we have to do? We have to factor out the GCF. It means we have to take these factors out. Okay, how we can write then? We can write the expression as x square and x minus 2y. Okay, then plus 3y square and x minus 2y. Now note one thing here. When you will factor them like this, then this term and these terms should be same. If they are not same, then it means there is you have made some mistake, or you cannot solve the given expression by using this method. So they have to be same. Now as they are same, we can write this expression as, we will write these two as ones, and we can write as x minus 2y and then the expression made up of x square plus 3y square, x square plus 3y square. So this is the answer of factorizing the given expression by making the groups. Let's have one more example. So example number 2. Okay, you will be asked to factorize x square minus y square into z plus y square minus z square into x. Okay, you have to factorize the given expression. Now how you can do that? we will start from here x square minus y square into z plus y square minus z square into x. Okay. First of all, we will multiply the terms that are outside the brackets by all the terms inside the bracket by using the distributive property. So you can write as x square z minus y square z plus xy square minus xz square. Okay, what we have used here? We have used here the distributive property. Okay, now we are moving towards making the pairs. Okay, this next we will see which of these terms can be grouped together. So for that purpose, we have to see how much minimize we can do this. We can do with this expression. Okay, so the pairs can be made as this is one pair and this is one. Okay, as by pairing like this we can minimize the expression as much as we can. So we can write them as x square z minus xz square minus y square z plus xy square. Okay, then we will again use the method of GCF. We have to factor out the GCF. Okay, so here in this expression, the GCF is xz, and in this, the GCF is y square. Okay, so we can write the above expression as we will take the GCF out as xz, and we will write x minus z. Okay, then we will take plus y square, as the y square is the GCF, and it will be at minus z plus x. Okay, then we will rearrange the terms x minus z plus y square into x minus z. Now it is clear from here that these are same, so we can write the expression as x minus z into xz plus y square. So this is these are the factors of the given expression. So we have to write the step-by-step process where what we have done. We have made groups here. Okay, then we have factor out the GCF here, and then we have factor out x minus 2 here, x minus 2, and we have rearranged here as rearranged. Okay, so these are the step-by-step process for solving a given polynomial that can be solved by making groups if it is not possible for the given polynomial to take the common factor out of all the given terms. So that's all from today's lecture.
Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.